know when? After the revolutionary inventions of the automobile, airplane, radio, cinema, and the beginning of electrification at the end of the 19th century. Another new technological order began in the world. We will talk about the new realities of the 30s and how this was reflected in the development of radio engineering in this video. Second half of the 19th century was extremely turbulent and productive in terms of revolutionary technical inventions that radically changed the world in its development and changed the lives of the inhabitants of planet Earth. The automobile, cinema, phonograph, radio were invented, power grids in large cities were rapidly being developed, and at the beginning of the 20th century the airplane appeared. All these inventions developed successfully, but had a rather limited range of users and were used mainly by state, military, or private industrial structures, as well as a small number of wealthy segments of the population. A vicious circle was created. Because of their high cost, they had a limited market sector, and because of their limited market share, they could not be mass, cheap, and accessible to everyone. Everything changed with the great financial crisis of 1929, known as the Great Depression. In order to survive in difficult times due to the threat of lack of demand for their expensive products, it forced large companies to reconsider the strategy of production and consumption of goods and services in society, and make them accessible to all strata of the population. Expensive goods were not in demand and their supply sharply decreased, only cheap and necessary things were sold. And here suddenly there were reserves to produce much cheaper and more accessible modern, expensive and perfect radio receivers of the superheterodyne type, which were very expensive before the crisis. This happened due to the expiration of the monopoly ownership of the superheterodyne patent, which RCA Corporation owned until the end of 1930, thereby artificially restraining competition in the superheterodyne market for 10 years. Already in the following year, 1931, RCA's competitors, Atwater Kent, Philco, Zenith, Crossley and others, offered their superheterodyne models, and RCA itself launched its relatively affordable, but very high-quality famous 8-tube model R7. And how did the then rather poor pre-war Europe react to new development opportunities? Unfortunately, with a delay, due to the general poverty of the population, and then the Second World War. 2- and 3-tube radio receivers of the regenerative type were manufactured in poor Europe until the early 1950s. And the first mass-produced affordable 5-tube superheterodynes began to appear on the market in 1933. All that existed before that were rare, small-scale experimental expensive products. And the pioneers here were, of course, the German companies Siemens, Telefunken, Lorenz, Mende, Blaupunkt, the Austrian Minerva, Radian and Ingelen, and of course, the ubiquitous Dutch Philips. So, today the story is about one of the first European mass-produced superheterodynes and one of the first superheterodynes with the short-wave range. The German 5-tube all-wave Lorenz model Super Celohet 33W of 1933. What is it? In general, it is always most interesting to study the period of the emergence of any technical product, when its concept is just being formed during the transition from experimental samples to the creation of concepts of varying degrees of perfection and efficiency. That is why, as a researcher of technical antiquity, I am most interested in the period from 1930 to 1935. It was during this time that the superheterodyne grew up. turned from a teenager into an adult young man and took shape as a concept of high quality, but affordable radio. And this model from Lorenz is a bright representative of radio receivers of this period, made extremely high quality, but on a principle sufficient for high quality reception in small Europe. Without excessively high technical characteristics, typical, for example, for radio receivers made in the USA. Therefore, this receiver does not have a high-frequency amplifier, which would greatly improve sensitivity and selectivity, but would also greatly increase the cost of the radio, and is a classic 5-tube superheterodyne with a single-tube frequency converter. A single-tube intermediate frequency amplifier and a single-switch 2-tube sound amplifier, which is more than enough to receive all powerful European radio stations. As we can see, radio tubes of the old digital series with a 5-pin socket of the early 20s were used here. It was extremely difficult to achieve high-quality operation of the Super on such radio tubes due to their limited design characteristics and unstable operation at high frequencies. In addition, the production line of this type of radio tubes still lacked high-quality frequency converting radio tubes of the triode-heptode type. And simpler pentagrids were only being created and were constantly being improved due to their imperfection. Because of this, our experimental Super also has the problem of low sensitivity on short waves, but nevertheless, to my surprise, there is a very decent sensitivity and selectivity on medium and long waves. Unlimited respect to those designers who managed to create a high-quality product from what was available at hand. And only high-frequency radio tubes of the Lorenz 1234 type were available. One by one in the mixer and intermediate frequency amplifier stages, the Lorenz 1254 diode pentode as a detector and the first stage of the sound amplifier, and the Lorenz 1374 as an output stage, and the rectifier on the RGN 1064 as a power source from the AC network. In 1934–1935, the radio tubes of the A and C series were developed and began to be manufactured. And the operation of all superheterodynes on such radio tubes became much better and more stable on all ranges. Immediately striking is the unusual design of the scale, more characteristic of military equipment. The arrow familiar to all of us, which runs back and forth on a fixed scale, is not here. In the middle of the drum made of translucent film with the values of the wavelengths of the transmitters and the names of the radio stations, 3 multicolored backlight bulbs are installed, which switch depending on the selected range and illuminate the sector of the selected range with the name of the radio station and the length of its radio wave. Agree. It is very convenient and informative. For the sake of such a design, it was necessary to change the arrangement of internal nodes, and therefore the location of the variable capacitance capacitor is also unusual here, not in the center of the chassis, but in the corner of the chassis with a 90-degree turn. I can't remember even one other similar design of a European superheterodyne. Nothing surprising, because Lorenz has long been a contractor for military and government contracts for the supply of communications equipment for the government and the Wehrmacht. Since the receiver was designed and sold for the middle class, we see a rather elegantly designed case with excellent finishing with beautiful walnut veneer, which was a rarity for German radio receivers in the 30s, well, except for premium class receivers. At first, I was surprised by the presence of as many as 5 knobs as controls for the radio receiver and could not understand the function of the left of these 3 knobs on the front panel. It turns out that this is the receiver sensitivity regulator, which protects the input stage from overload when receiving powerful local radio stations, and the sound from distortion. There is nothing to be surprised about. Automatic gain control with the now familiar abbreviation AGC was invented only a year earlier, and for its implementation the industry had not yet produced special radio tubes. Another strange thing here is that for maximum sensitivity on medium and long waves, this regulator should be in the extreme right position, and for receiving short waves, in the extreme left. An obvious contradiction. You can easily get confused. Until I understood this, I tormented this radio on the repair table for a very long time. A very, very strange design feature. And in general, this radio pleased me with its excellent ergonomics. That is, ease of use, of course, except for this handle, and a very pleasant velvety sound, which German tube radios are famous for. This is where I end the story. Who liked it? Comment, like, subscribe. And from the next video we move on to a review of early rare superheterodynes of the early 30s from the United States of America. That's when America, despite the crisis, was really great.
Nagyon sok mindent tudtam Jézusról, de akkor azt mondta nekem ott, hogy most már épp itt van az ideje, hogy átadjam az életemet. Sokan megtérni. Az ő megtérése viszont nem csak azért, mert ő a férjem, tipikus párforduló.